complex numbers. In the last class, we discussed about the basic facts of complex numbers. Now, let's do a few problems related to complex numbers. A few basic problems. Okay. Suppose if you get a question like solve the equation z square plus 4z plus 5 equal to 0. What shall we do? Okay, so though it is a question from complex numbers, we never need to worry about this one. So what we need to do is just do the method of solution by using quadratic formula. So we get z is equal to, as it is complex number, the equation is mentioned with z minus b plus or minus square root of b squared minus 4ac divided by 2a. So here you need to remember one thing you learned in quadratics about the nature of the roots. There, when we are discussing about nature of the roots, there we were discussing with 4ac. If b squared minus 4ac equal to 0, roots are real and equal. B squared minus 4ac greater than 0, then roots are real and distinct. And if b squared minus 4ac less than 0, there we learned roots are not real. That means roots are imaginary or roots are complex roots. So now you might have understood why we are getting roots complex here, because b squared minus 4ac is negative. As b squared minus 4ac is negative, we get square root of a negative number. As per the definition of complex number, square root of a negative number is always always imaginary. And the first imaginary number is root of minus 1, that is assumed as I. Okay, so now here let's substitute the values. We get minus 4 plus or minus square root of 4 squared minus 4 into 1 into 5 divided by 2a, that is 2 times 1, which is 2. That is equal to minus 4 plus or minus under the root. When you do this one, what do you get? 16 minus 20, that is minus 4 divided by 2, which is minus 4 plus or minus. We have learned root of minus 4. Root of minus 4 can be written as root of minus 1 into 4. That is root of minus 1 into root of 4, which is same as 2i. So root of minus 4 is 2i whole divided by 2. Yes. It can be still simplified by taking 2 as common in the numerator. So we get, if 2 as common, we get minus 2 plus or minus I divided by 2. So 2 and 2 get cancelled. So we get the roots are minus 2 plus I, and the second root as minus 2 minus I. So normally we denote this root as alpha and this root as beta in our solution. And you check alpha and beta, they always related each other in complex. Like if alpha is x plus iy, then beta will be x minus iy. That's a relation between the roots. If the first root alpha is 2 plus 3i, then the second root beta will be 2 minus 3i. That is why we say roots are conjugate to each other. Roots are conjugate to each other. Okay. Now look at this question. Find the value of x and y if x plus 2y plus I of 3x minus y is equal to 1 plus 10i. Okay, so when you get a question like this, what method can be used? So here we can use the method of equal complex numbers. Like if x plus iy is equal to a plus ib. If x plus iy is equal to a plus ib, then we can say x is equal to a and y is equal to b. Nothing but equate the real parts and equate the imaginary parts. Means if two complex numbers are equal, then their real parts are equal and imaginary parts are also equal. So this concept can be used in this question. So that we get x plus 2y is equal to 1. 1 is the real part. And 3x minus y. 3x minus y is the imaginary part with I. So imaginary part with I is 10 here. So now we come to the concept of simultaneous linear equations. Okay, so there we have to use the solution, solve these two equations. So when you want to solve these two equations, you can use either elimination method or substitution method. I'm going to use elimination method here. For that, I am multiplying a 3 in the first equation. So we get 3x plus 2y is equal to, 3x plus 6y is equal to 3 when you multiply 3 throughout the equation. And the second equation remains same. Now you might have understood why I multiplied 3 in the first equation. Now do subtraction. When you subtract, it gets cancelled, and here we get 6y minus y, that is 6y plus y, which is 7y, is equal to 3 minus 10, which is minus 7. So y is equal to minus 7 divided by 7, that's equal to minus 1. Now substitute this y value in any one of these equations. We get the value of x. Let me take this equation. We get 3x minus y is equal to 10 implies 3x minus 1, because y is minus 1, is equal to 10. That implies 3x plus 1 is equal to 10, or 3x is equal to 9. That gives us the answer. X is equal to 9 divided by 3, which is 3. Okay. Now another basic question you could find from complex numbers is expressed in the form of x plus iy. Expressed in the form of x plus iy. For that, let's take one question. 1 plus 3i into 2 minus I. Let's see how to express this in the form of x plus iy. The work is very simple. Though it is complex number, already I informed you we have to use the normal mathematical steps. So here we have learned in our primary classes, when we get two binomials to be expanded, we need to multiply each and every term. That means expand the bracket. Expand the bracket. So when we do that, we get 1 into 2 as 2 plus 1 into minus I as minus I plus 3i into 2 as 6i plus 3i into minus I as minus 3i squared. That is 2. The middle, these two terms gives us the like terms. So 6i minus I is plus 5i minus 3. And we know I squared is minus 1. This is a basic fact you have to remember, as I is root of minus 1 and I squared is minus 1. So we get the result as 2 plus 5i plus 3, or if we add 2 and 3 together, we get 5 plus 5i as answer. Okay. If you find a question like this, like minus 1 plus 11i divided by 6 minus 5y, this one should be expressed in the form of x plus iy. What can we do here? So in such situation, you have to remember the concept of complex conjugate. Complex conjugate. We discussed in the last class about complex conjugate, but we recall once again what is complex conjugate. If z is a complex number, let it be x plus iy, then its complex conjugate is z star, which is x minus iy. Look at this. If we compare this one with roots, this is alpha and this is beta. So if z is alpha, then its complex conjugate will be beta. Okay, now why it is known as conjugate? Because if you take the product of z and z star, that means if you multiply z and z star, it looks like x plus iy into x minus iy. Here you have to remember the formula: a plus b into a minus b is equal to a squared minus b squared. So when you take this, we get x squared minus iy the whole squared. Yes, a plus b into a minus b is equal to a squared minus b squared. So we get it as x squared minus I squared y squared, which is equal to x squared. I squared is minus 1. So minus into minus 1 is plus 1 plus y squared. So we get z into z star is equal to, that is product of a number, complex number, and its conjugate is x squared plus y squared, which is a real number because there is no I in this. So what you are getting, product of two complex numbers is a real number. Product of two complex numbers is a real number. Then we call each of these complex numbers as the conjugate to each other. Conjugate to each other. Okay. So what is the conjugate of 6 minus 5i? Yes, it is 6 plus 5i. And remember, when we do a question with fraction in complex numbers, make sure you are changing the denominator into real number. Now the denominator is a complex number that to be changed to real number. And now itself we have seen the product of a number and its conjugate is real number. Product of a number and its conjugate is real number. So to make this denominator as a real number, you have to multiply its conjugate here. Multiply the conjugate. But we are not allowed to multiply a number only in denominator. So we have to multiply the same conjugate in numerator also. Understood what we have to do? Okay. And you know the conjugate of 6 minus 5i is 6 plus 5i. So we have to multiply the conjugate of the denominator. Remember, conjugate of the denominator. Because our task is to change the denominator as a real number. So the conjugate of 6 minus 5i is 6 plus 5i. As we multiplied 6 plus 5i in denominator, the same to be multiplied in numerator also. As it's a binomial, let's put in bracket. Now our work is very simple. Do normal calculation. Expand the bracket. Like minus 1 into 6, minus 6, minus 1 into 5i, minus 5i, 11i into 6, that is 66i, plus 11i into 5i, that is 55, I squared, whole divided by, it looks like a minus b into a plus b. Always denominator will be that, a minus b into a plus b form, which is a squared minus b squared. So it looks like 6 squared minus 5i squared, which gives us the numerator as minus 6. When you do this like terms, these both are like terms. We get plus 61i, so 66 minus 5. I squared is minus 1, so we get it as minus 55 divided by 36. I squared is minus 1, so minus 1 into minus is plus, 5 squared is 25. That is minus 6 minus 55 is minus 61 plus 61i, the whole divided by 36 plus 25 is again 61. So still we can simplify it because numerator has 61 in both the terms. So if we take 61 as a common term, we get remaining minus 1 plus I divided by 61. So that this 61 get cancelled. We get the answer as minus 1 plus I in the form of x plus iy, where y is 1. Okay. Another type of question you can expect from complex numbers as find the quadratic equation if both the roots are given. And remember, for complex numbers, we don't want both the roots. If you get one root itself, you can identify the next one. Check this one. One root is minus 7i. So the second one is plus 7i. Okay, whatever. If alpha and beta are the roots, if alpha and beta are the roots, then we can say that means x is equal to alpha and x is equal to beta. Here we can call it as not x, it is z, as it is complex. So what do you mean by roots? Roots are nothing but the solution, the value of the variable. Our variable is z. So if alpha and beta are the roots, that means z is alpha and z is beta. That means our factors are z minus alpha and z minus beta. And if we multiply these two, we get the equation, that is quadratic equation. That is, if we multiply, we get z squared minus alpha is z minus beta is z plus alpha beta is equal to 0. Just multiply, just expand the bracket. So when you expand it, when you make it as the next step, these two are like terms because z minus z is common. If you take minus z as common, remaining we have here alpha plus beta plus alpha beta is equal to 0. So instead of using all this step in each and every problem, you can use this equation directly. You don't need to do all these things in every problem. That makes us in confusion and time consuming. So let's use this formula directly. And that formula states that if alpha and beta are the roots of a quadratic equation, then the quadratic equation will be z squared minus alpha plus beta z, that is sum of the roots plus product of the roots is equal to 0. Remember splitting the middle term. In splitting the middle term must be sum and the last term should be product. That's same thing. Okay, once again, if alpha and beta are the roots of a quadratic equation, this is not only for complex numbers, this is applicable for the whole number system. Okay, so if alpha and beta are the roots of a quadratic equation, then the quadratic equation is z squared minus alpha plus beta z. Remember, minus alpha plus beta z plus alpha beta is equal to 0. Z squared minus sum of the roots of z plus product of the roots is equal to 0. Okay, so this is the concept we are going to use to find the quadratic equation. Now let's replace the value of alpha and beta in this. We get z squared minus alpha is minus 7i plus beta is 7i z plus alpha beta, that is minus 7i into beta 7i is equal to 0. That is z squared. When you do this calculation, the next step is you have to simplify the bracket to be simplified, middle term bracket. We get 7i minus 7i is 0. That is the middle term becomes 0. So no need to write that, as 0 means the term is cancelled. So what do you get here? Minus 49 I squared, 7 sevens 49 I squared is equal to 0. But you know I squared is minus 1. So it gives us z squared minus 49 of minus 1 is equal to 0, or we get it as z squared plus 49 is equal to 0 as the quadratic equation. Another question, find the quadratic equation where alpha is minus 5 by 2 minus root 31 by 2i and beta is minus 5 by 2 plus root 31 by 2i. Let's replace in the quadratic equation. We get z squared minus alpha. Alpha is minus 5 by 2 minus root 31 by 2i plus beta, which is minus 5 by 2 plus root 31 by 2i of z plus alpha into beta, that is minus 5 by 2 minus root 31 by 2i into beta minus 5 by 2 plus root 31 by 2i is equal to 0. That implies z squared minus, let's solve the bracket, simplify the bracket. When you look at the bracket, we get minus 5 by 2 minus 5 by 2. Like terms. and minus root 31 by 2i plus root 31 by 2i get cancelled because one is negative and one is positive. Like terms with the negative and positive, equal terms. Plus, now it looks like a minus b into a plus b, where a is minus 5 by 2 and b is root 31 by 2i, which is a squared minus b squared. Use that. This is like a minus b into a plus b. You know that is a squared minus b squared. So we get it as minus 5 by 2 squared minus b squared, that is root 31 by 2 I squared is equal to 0. That is z squared minus, minus 5 by 2 minus 5 by 2 is minus 10 by 2, that is minus 5 itself. Plus, here we get, when you simplify it as, it is 25 by 4 minus root 31 squared is 31 by 2 squared is 4 I squared is equal to 0. Now we can make one more change, that is I squared. Look at, this is the second concept of complex number we are using in this. One concept is one root is x minus iy, the second root will be x plus iy. The second one is I squared is minus 1. Remaining all normal mathematical calculation. So it gives us z squared plus 5z plus 25 by 4. I squared is minus 1. So we get minus 1 into minus plus 31 by 4 is equal to 0. That gives us z squared plus 5z. When you do this one, you get 25 by 4 plus 31 by 4 is 56 by 4. 56 by 4 is 14 is equal to 0 as the quadratic equation. Another question, z is equal to 5 plus I root 3 is a root of the quadratic equation. Find the quadratic equation. Okay, so one root. So z is equal to 5 plus I root 3 is a root. Let's take this root as alpha. Is 5 plus I root 3. So what will be the next root beta? Yes, it is 5 minus I root 3. Okay, so our quadratic equation is z squared minus alpha plus beta z plus alpha beta is equal to 0. So when you replace, we get z squared minus 5 plus I root 3 plus beta is 5 minus I root 3 plus alpha into beta, that is 5 plus I root 3 into 5 minus I root 3 is equal to 0. That implies z squared minus, when you simplify the bracket, sorry I forgot z here, I root 3 minus I root 3 get cancelled, remaining we have 5 plus 5, 10. Plus, it looks like a plus b into a minus b, that always like that, which is a squared minus b squared. So we get 5 squared minus I root 3 squared is equal to 0. That is z squared minus 10z plus 25 minus I squared is minus 1. So minus into minus, it becomes plus. Root 3 squared is 3 is equal to 0. That implies z squared minus 10z plus 28 is equal to 0 as quadratic equation. In an electrical circuit, the voltage, current and impedance are related by voltage is equal to current into impedance. The voltage in a particular circuit is 240 volt and the impedance is 48 plus 36 I ohms. Find the current. Actually, it's a very simple question. It's given that voltage is current into impedance. So voltage, you know, it is 240 is equal to current multiplied by impedance as 48 plus 36I. We want the value of current, so take this onto this side, normal calculation of mathematics. So we get current is 240 divided by 48 plus 36I. But now the use of complex numbers come. See here, the denominator is a complex number, so it should be multiplied by its conjugate, that is 48 minus 36I. So the same to be multiplied in numerator also. We get 240 of 48 minus 36I all divided by a plus b into a minus b, that is 48 squared minus 36I squared, which is equal to 240 of 48 minus 36I divided by 48 squared. I squared is minus 1, so minus into minus it becomes plus 36 squared. Go on with calculation and find out its answer. We get 3.2 minus 2.4 I amps as the voltage. Okay. In the next class, we will be discussing about the complex plane, Argand diagrams, modulus argument form, principal argument, and the corresponding problems related to these topics. Thank you.